Welcome back. Algebra 2, we're in lesson 74 today. About 9 lessons ago in lesson 65, so it wasn't about 9, it's exactly 9 lessons ago in 65, we learned how to do the advanced substitution with our uniform motion problems. We're not learning anything different about the uniform motion problems today in lesson 74. What we're going to do is just learn how to pull out the information and create our own beginning equations so that we can solve. So let's read this. Friar Tuck rode the 24 miles to the fair in Nottingham at a leisurely pace. He stayed too long at the fair and had to double his speed on the way back in order to get home in time. If his total traveling time was 9 hours, how fast did he travel in each direction? What were the times? So we have the information that we need here in order to solve. It's just written without numbers. So that's something that you need to look for when you read is what the words are that have to do with math. You know, anything double, triple, numbers that are spelled out, those are the things you're looking for. So let's see if we can create our equations based off of this information. This is the only mathematical information we have. So we know that it was 24 miles to get there. So that tells me we can draw our little thing here. 24 miles on the way there and 24 miles on the way back. So on the way there, let's call that going. And let's say that B is on the way back, right? So 24 miles there and back. So we can make two equations based on this. We can say the rate going times the time going was equal to 24 miles because the distance was 24 miles and this is the distance. We can also say that the rate back times the time back is equal to 24 miles. That's pretty easy to do with just this one little bit of information, right? We got this one diagram, which gave us these two equations. So you're going to want to write all that down, how you do that. All right, so this was information 1, and we got all of this from information 1. All right, let's do information 2. Information 2 says that he had to double his speed on the way back because he stayed too long. So he doubled his speed on the way back. So his rate going was the same as 2 times his rate back because he had to double the speed on the way back. All right. No, I'm sorry. I got that backwards. His rate back, he doubled his rate back. So that means that that was 2 times the rate going. That could be a little tricky. You have to think about that. Just as you can see, I made a mistake myself. But you have to think about it. So if he doubled his speed on the way back, that means that his rate, his speed, was twice the speed of his way going. So that's what we did here. That was information 2, right there. Let's see what we can do with information 3. Information 3 tells us that his total traveling time was 9 hours. So there and back was 9 hours. So that tells me that the time going plus the time back is 9 hours. We have all the equations we need in order to solve this. From those 3 bits of information, we were able to make all 4 of our equations that we need. So now let's go ahead and solve this. So we're going to start with RB, TB. We're going to start with his rate back times his time back. And the reason we're going to do that is because we can solve here and say, we're going to subtract this and say the time back is equal to 9 minus the time going. All right, so there's our substitution. And we already have RB solved for right here, so we can sub both of those in. So 2 times the rate going, and then the value for TB is 9 minus TG equals 24. So now we can multiply. Okay, that's going to be 18 RG minus 2 RG TG equals 24. We already know what RG/TG is, so we can sub that in. So 18 RG minus 2 times 24 is equal to 24. So we know that this is going to be negative 48. So if we add 48 to both sides, I'm going to put that up here because I'm starting to lose room. So 18 RG is equal to, that's going to be 72. Yeah. All right, so now all we do is we divide both sides by 18, which I'm going to need a calculator for because I can't do that in my head because I'm not that smart, is 4. All right, so RG is equal to 4. How about that? So I'm going to write up here what our actual values are. RG, TG, RB, and TB. Now, if RG is 4, then TG has to be 6, right? Because RG times TG is 24. So if I say this is 4, then I divide both sides by 4, TG is 6. So now I know what TG is. And why did I write a G? I guess because I said G. That should be 6, right? So now we can solve for RB because we know that RB is 2 times RG. So if RB equals 2 times RG, RG is 4, RB is 8. And now, because of that, I could say RB TB is 24. If RB is 8, then TB, divide both sides by 8, TB is 3. So now you have all of your values. All right, so it's not so hard once you kind of figure this out. This is the same exact stuff we did in lesson 65. We just had to get our equations to start with. And it does look a little bit messy on this page, but I'm sure that there are those of you who are much more organized than I am who can do this a little bit better and keep it a little bit more neat. If you can, God bless you. If not, then welcome to the club. All right, so let's do one more and then we'll move on. All right, I'm going to clear the page. And once I clear the page, I'm going to put up another one, okay? All right, so here's our second problem. And it says Atlanta ran 4 times as fast as her challenger. In fact, she ran 80 miles in 2 hours less than it took her challenger to run for 28 miles. How fast is your them run? Okay, so here's what I did. I dictated this so I didn't have to type it because my typing isn't great either. How fast, let me correct this. This is not what that's supposed to be. Come on. My computer is like taking its own sweet time. Do y'all see what I go through for you guys? I just slave over this computer and try to make it look easy. It should say, how fast did each of them run? And how long did they run? Apparently my diction is terrible. All right, now that's correct. All right, let me get my highlighter and let's go ahead and read through this again. Atlanta ran 4 times as fast as her challenger. In fact, she ran 80 miles in 2 hours less than it took her challenger to run 28 miles. So we have our 3 bits of information. So now we can look at our problem. So we know that she ran Atlanta, here's Atlanta, she ran 80 miles. And her challenger ran 28 miles. So Atlanta ran 80 and the challenger ran 28. So we have our first 2 equations. So we have RA times TA equals 80 and RC times TC equals 28. All right, there's our first 2. So now let's look at the next bits of information. We reread the problem and we write the rate equation and the time equation. So she ran 4 times as fast as her challenger. So Atlanta, the rate of Atlanta is 4 times the rate of her challenger. So 4 times the rate of the challenger. Okay. And now let's look at her time. She ran the 80 miles in 2 hours less than her challenger. So her time minus 2 hours is her challenger's time. So that's going to be Atlanta's time is her challenger minus 2 hours. Okay? She ran 80 miles less. So this was 1 and 2, 3, and 4. Because some of it's kind of combined, right? So this was the 1, 2 hours less, that's 2. So 1, 2, 4 times, this is 3, and then this was 4. So that's our 4 bits of information and where we got it, what it did for us. Okay, now we can solve the problem. Easy way. So we're going to start with Atlanta, because that's who we're talking about. RATA equals 80. And also because we already have RA and TA solved for. And that's how you make that decision. What do you already have solved for? And then that's the one you're going to pull and use to begin. So RA is 4RC. And TA is TC minus 2. That equals 80. Now we can multiply. So we have 4RC TC minus 8RC equals 80. Well, we know what RCTC is. It's 28. So 4 times 28 minus 8RC is equal to 80. 4 times 28, that's going to be 4, carry the, no, that's not 4, it's 2. Hello, 4 times 8 is 32. So 2, carry the 3, that's going to be 112. Minus 8RC. I'm going to subtract that from both sides. So negative 8RC is equal to negative 32. All right. Because they're both negative, I'm just going to swap it. I'm going to multiply both of these times a negative 1. So we get 8RC is equal to 32, because I just hate dealing with negatives. And as long as I do it to both sides, then it is fair. Now I just divide both sides by 8. I get that RC is equal to 4. All right, so I can start putting my information over here. RC is equal to 4. TC is equal to what? I don't know. RA is equal to something, and TA is equal to something. So if RCTC is 28, so if RC is 4, then I can do 4TC is equal to 28. So that means TC is equal to 7, because 4 times 7 is 28. So that is solved for me. And now I could take this one and I can say that if TC is 7, then TA is equal to 7 minus 2, so TA is equal to 5, right? So if RATA is equal to 80 and TA is equal to 5, divide both sides by 5, RA is equal to 16. How about that? Easy peasy. Once you get that first bit of information, it helps you solve the rest of it. And it makes a huge difference. Guess what? That's all we have for lesson 74. I will see you in lesson 75.